So we're going to look at testing the ring final circuit now. We're going to assume that we've nulled the leads and we've checked the meter for condition and calibrated just to speed things up a bit. So we're happy that the meter is okay and we've nulled the leads. So the first test we're going to do is we're going to test end to end on the line, neutral and CPC to make sure we've got a ring and no breaks in any connections. So we're going line to line. You don't need to press test button, do you? So we've got 0.18 on the end to end on the line conductor, and it's important that we record that. Yeah, so 0.18 ohms end to end on the line conductor. So we're now going to do the neutral end to end.
0.19,
and we've got neutral, which is 0.19 ohms. So neutral's 0.19, and then we're going to do CPC to CPC.
That's coming to 9 reading that is.
0.2. Yeah. So we've got CPC equals 0.2 ohms. Explain what we're doing now while we're doing it, yeah? Tell me one.
Yeah.
Right, we've just done the end to end on line, CPC and neutral, and that's just to make sure that we've got a ring and we've got no bad connections all the way around the ring on line, neutral and CPC. What we don't know is if the ring's actually wired up correctly at each socket. All we know is we've got a ring. So the next test is going to prove polarity, are the sockets actually wired up correctly. So what we've done is we've shorted out the outgoing line to the incoming CPC and the incoming line to the outgoing CPC, cross-connected as we call it. Yeah? We're now going to test between line and neutral at each socket to see if we have actually got a line and neutral at each socket. Now the readings should be the same at every socket, other than a spur which will be slightly higher.
.16.
Right, so check every socket. Very close. 0.16.
And this one's a spare.
It is important that you check every socket because every socket needs to be wired correctly. That's slightly higher. This is working good, isn't it? Yeah. Right, so that's good. How did we come to that? Well, we have to do R1 plus Rn divided by 4. So that equals 0.18 plus 0.19 divided by 4, and that gives you your R1 Rn value, and then your R1 R2 value would be 0.18 plus 0.2 divided by 4. So we have to calculate those values. It's really important that we get the values that we've calculated. Right, stop it now. So now what we've done, just to recap, we've done end to end to prove we've got a ring. We've done R1 Rn to prove we've got a line and a neutral. We've showed how we work out for R1 Rn and R1 R2, which is really important that we do this maths first because we need to know what this equates to for the reading and what this equates to for the reading. Yeah? So we're now going to do the R1 R2 test. So we've cross-connected the line and the CPC, so we've got the outgoing line to the incoming CPC and the incoming line to the outgoing CPC. So they're cross-connected as such, and now we're going to check between line and CPC at every socket, and the readings should be identical to what we've calculated, other than at a spur, which is going to be slightly higher. So it's line and CPC this time. And again, we've got a reading 0.18, yeah. So if we move it and check it the other socket, 0.16, yeah, they're all reasonably identical. 0.16 again. So now, at this point, what we've done, just to recap, we've tested end to end and recorded the values. That proves we've got a ring. Those values we then put into these two equations to get an answer for R1Rn and R1R2. For this then, we cross-connected the outgoing line to the incoming neutral and the incoming line to the outgoing neutral and tested at every socket and got the answer that this equates to. We then did the same but cross-connecting the line and the CPC, and this is the equation that we work out what the answer is, and it should be the same at every single socket. That proves now we've got a ring and the line and neutral and line and CPC are correct in every socket, which is correct polarity. Right, we're now going to check for insulation resistance. So what we're checking now is the PVC on the cable. We're not checking the copper. The copper's being checked on continuity. Key point, make sure nothing is plugged into the ring. Unplug everything from every socket. So there's nothing plugged in anywhere that could be damaged by this 500 volt test. And we also want to make sure nobody's touching any metalwork, because I say the test is done at 500 volts. There's three tests we're going to do. We're going to test between line neutral, line earth and neutral earth. And they should all be greater than 299 ohms. So between line and neutral, just make sure that's on the copper. We're set on 500 volts, and you have to hold the test button in for this, and that's going to be greater than 299 megohms. Yeah. Then we're going to go line to CPC. So we're going to go line to CPC, and again we're going to check that greater than 299 megohms. Yeah. And then we're going to do neutral to CPC, and again making sure we're greater than 299.
CPC.
Oh, sorry. Sorry, my mistake. Wrong. Neutral CPC greater than 2999 megohms. Now we're allowed to go down to 2 megohms where you would investigate it, because it's obviously a very low reading, or if we get below 1 megohm, then that's a fail. The circuit's got to be failed and the fault found and rectified.
Shoot them.